So in today's of our video, we are going to explore out the household circuits. So basically here you can see the bigger circuit breakers and this one is the smaller one with an ammeter attached to it. So let's take a closer look at these things. So let me remind you that the room lights will go when the circuit breaker breaks off. So let's first take a flashlight and let me show you how the circuits are connected. So basically these are the circuits. So here you go, the lights go off when we turn off the switch, and really carefully we got to turn this back on and the lights is on. So here we have a small ammeter and this light takes a puny current. So here this is the main circuit. So the whole setup is a very controlled setup. So now to make this setup safer, what we have done is this is the main bigger block of multiple circuit breakers and this one is a very small one. So this one is designed to power up only one unit, but whereas we are going to connect several different units and check out if the things work properly or not. So here as you can see, this is designed for 30 amps of current and now we are going to load the things up. So basically these lights take a really small amount of current. And now let's turn off and turn on a bigger load. So as the fan starts, it takes a bigger load, and let's turn on this air conditioner on, even a bigger load. As you can see, the amperage goes up till 15 amps, and there you go, we have 3 of the loads connected. So now as we reduce the load, the amperage decreases. Still we got the fan, turn that off and lights. There you go, now it's all in 0 amps. So basically now what we have done is connected the circuit breakers in series. So now when I turn this main circuit breaker off, the whole setup turns off even though these circuit breakers are on. So basically this is the master switch of our whole circuit, and there we go. So now what we are going to do is short the circuit these 2 terminals and see what happens, and let's go. So to make the experiment really dodgy, we are going to cut off the maximum amount of load. So basically we are turning off the bigger loads and letting this light stay on, and make sure that you are grounded and you do not touch any of the terminals right here because there are live wires and you can short yourself. So basically what we are going to do now is just create a dead short between these 2 terminals. So now let us turn on the lights and there we go. Now we have everything, and now let's just create a dead short and not make big stories. So basically you guys are supposed to be focused on the ammeter and the multiple circuit breaker right here. So there we have the wire, and thing recommended is to hold it with pliers, but who cares. So let's put the pliers aside and create a short circuit. So let's create it now. So as you can see, the ammeter goes above 30 amps and of course the current is much more than 30 amps. I have to be little cautious because it's mains voltage. Everything went smoking, and as you can see, yep, there's a lot of smoke. I'm gonna get beaten today, and yeah, somehow this MCB tripped down, and as you can see, it saved the house from burning. So now when I'm going to turn this MCB on, my stuff should be back up. By the way, where did I drop on the wire? It was hot as hell. So let's first cut off the whole circuit, turn this thing on, and now nothing up, everything is up back. So let's just turn bigger loads. There we go. everything is working nice. Let's create the storage circuit once more. This time what we are going to do is use the pliers instead of the wire, so that we can get the maximum dead shot and the quickest time. There we go. Only a dead spark and everything goes down. So basically we are going to turn this on back, and yep, everything goes on back. So basically this is how multiple circuit breaker works. It acts as a fuse in a circuit, and it's easy to turn this back on. It only takes a few seconds. So that's all for today's video. Bye.